Please introduce yourself.
My name is Christian Stiels. I work for Econ Industries as lead process engineer. For the last 10 years I've been working with norm-based projects, and there are many questions around the norm-based and many insecurities, so I will give you a short introduction on the norm-based.
What is norm and what does the acronym stand for?
Norm means natural occurring radioactive material. This means the material has a higher radioactive level than the background value or the normal material, but this is by nature, not by human activity. There's a second term called T-norm, which means technically enhanced norm-based, which is material that has higher radioactive levels due to human activities. One interesting fact about norm is that one material might be regarded a norm or T-norm waste in one country and not in another country. And to make it even more complicated, it also depends on the source or the industries if the material is regarded norm waste or non-norm waste. So as the same material with the same radioactivity level can be norm waste or not a norm waste.
Where and when does norm occur?
Natural radioactive materials exist throughout the world. They are brought to surface by human activities. In the case of T-norm, those norm materials the radioactivity of those norm materials are increased by further human activities, for example by concentrating actions. Typical sources for norm waste are the oil and gas industry, the mining of minerals and ore and the processing of the same, and the coal burning. These are the major sources of norm waste that are of interest.
Why is norm of concern?
Norm waste or norm material is of concern basically because of 2 points. The one point is that if you're exposed to norm-based material or to material that has a high radioactivity, it's more likely that you develop cancer or other diseases in the long run. Immediate health effects are usually not considered to be very serious in the radioactivity level the typical norm wastes are in. The second point is that the radioactivity usually stays there for a long time. So the radioactivity, depending on the elements, has a half-lifetime of several million years. So it's a hazard that persists for a very long time.
What type of norm wastes are there?
In the oil and gas industry, there are different types of norm wastes from different sources. The largest fraction is probably the equipment that is contaminated by scales that contain high radioactivity levels. This material has to be cleaned, which leads to sludge in form of the scales and rust and so on. The second part is often drill cuttings, which is the stones that are drilled for exploitation, for example. And then there are sludges, for example, from sludge catchers or the processing of oil and gas.
What do they consist of?
Many of these norm wastes are a mixture, really, a mixture of different materials, a mixture of oil, water, solids and sometimes mercury. So a typical sludge, for example, would look like this, and if you break it up, you have the solids, you have also the water, and you have oil. So it's really a mixture of those 3 phases, and sometimes also of mercury in addition.
What are the difficulties when treating norm waste?
The difficulties when treating norm waste is that it's not possible to destroy radioactivity. So the goal of all treatment can only be the reduction of human exposure to norm waste and the long-time stable storage of this norm waste.
How does vacuum-dry remediate norm waste?
Vacuum-dry, of course, also cannot remove the radioactivity, but it separates the fractions from the mixture, which the waste is. The waste is a mixture of oil, water and solids, like this. It removes the oil, which is then free of radioactive material. It removes the water, which is also free of radioactivity, and concentrates the radioactivity in the solids. The solids are then free of oil and water and can be immobilized. Why is it so important to immobilize the material? Because then it can be transported and handled safely. It reduces leachability and cross-contamination and allows a long-term storage of the material.
Do you have any applications?
Econ Industries have experience in planning and delivering plants for treating norm waste for more than 15 years. We have delivered installations to Europe and Australia. Some of the plants are running for more than 15 years now.
What quantities can be treated?
The vacuum dry process is a batch process, and typical quantities treated are between 1 cubic meter per day and 2 cubic meter per hour.
What are the greatest advantages of using indirectly heated vacuum thermal desorption to treat norm waste?
The vacuum dry process has many advantages for the treatment of norm waste. One of the main advantages is that it's a batch process. And due to the batch process, there's a very low off-gas volume of maximum 10 cubic meter per hour. A second big advantage is it's a vacuum process. And due to the vacuum process, we can process at lower temperatures, and at the same time it's not possible that we have leakages, for example radioactive emissions to the exposing the workers to radioactive material, because there can be no dust that gets out of the process during the operation. Another advantage is that when we use the vacuum dry process to dry the material and to create an immobilized matrix of the material, it's possible to have a safe handling and safe storage of the material, and the material is ready for safe disposal and long-time storage.